Good morning and welcome to today's webinar in Knowledge Miles, the 695th Lord Mayor's Lectures. Today we have an important safety lecture on fire risks involving lithium-ion batteries. In this free online lecture series, we address the connections in and around the square mile, the world's coffee house, and how these might help us to tackle future global challenges. I'm Peter Holland, Chief Inspector of the Crown Premises Fire Safety Inspectorate, and I'm also the Underwarden of the Worshipful Company of Firefighters. And the Worshipful Company of Firefighters, our prime objective is to promote the development and advancement of the science, art and practice of firefighting, fire prevention and life safety. And I'll be convening this session and moderating the question and answer portion of today's lecture. Before we get started then, a bit of housekeeping from me. My job, as always with these things, is to get out of the way as soon as possible because you haven't joined to listen to me. The agenda, as you can see in front of you, we straight into the presentation from Phil immediately after me, and then we have 20 minutes of question and answers. And just a little prompt here, if your question doesn't get answered, and we're expecting quite a lot of questions, Phil has very kindly agreed to handle those questions. And his website's going to be on there, so get your finger poised on your typewriter, or if you still have a pen and paper, by all means use one of those. Just a reminder that all the lectures are recorded and the recording will be available in a couple of days. But without further ado, let me introduce the speaker for today's lecture. We're delighted to have Phil Clark, the National Fire Chief's lead on emerging technologies, which of course includes lithium-ion batteries. Phil's an area manager with the Tyne and Wear Fire and Rescue Service, and I was delighted when I asked Phil if he would be prepared to do this, because I know from my direct contacts with him just how much he is aware of this issue, and we're very, very lucky to have him today. So Phil, over to you.
Thank you very much, Peter. Just bear with me while I share my screen. So hopefully now we can see the presentation, just sort my technology out.
Yeah,
so yes,
all
good
Phil.
morning. Brilliant, thank you very much for confirming. So good morning everybody, and thank you very much for the kind introduction, Peter. We've got a lot to cover with this subject area, and what I've tried to do is try and keep it high level, but I'm happy to delve into areas if there are questions which can be submitted through the chair, as Peter said before there. In doing this, I hope that I'm able to raise your awareness without scaring you or maybe over-sensationalizing the issue. Lithium-ion batteries, if used correctly, can bring huge positives for us, but we need to look after them. We need to look after them differently and maybe pay more attention to their safe use and how we charge them. So we're well on my journey towards net zero. The pace, I feel, and the change is so rapid at the moment in regulation. The regulation and guidance is lagging behind the pace of the development, which isn't uncommon for other technologies, but we've still got a lot to learn about renewable technology. And in the absence of regulation and guidance, often what I see in the built environment is an environment whereby there is nothing to say I can't do something, so I will. If we reflect back to 2013, renewable energy accounted for around 14% of the energy that was generated, and we've moved to a point in 2023 where we're generating around 40% from renewables. We've also moved from a position of how do we create energy to a challenge of how do we store all the energy. And batteries play a huge part in this. There's a huge investment in battery energy storage taking place at the moment for deployment across the UK and globally. These large batteries will help us capture the energy for times when maybe the sun isn't shining or the wind isn't blowing, and we need these to even out the peaks and troughs of demand on our national grid. In the UK, we've got around 160 sites presently, and that is due to grow exponentially in the coming years. Present government predictions forecast the UK will need around 30 gigawatts of flexibility in the storage of energy by 2030. There's been a huge increase of battery energy storages entering the planning pipeline over the last year. Whilst we need them as a country, in many cases they're not proven popular with members of the public. And what I often see is fire and rescue services being drawn into local issues, often incorrectly so on the grounds of perceived safety concerns with them. So lithium batteries are really important to us as they allow us to capture huge amounts of energy and store it in a small space. If you reflect back and think how over the years the size of portable electrical equipment has changed in terms of the weight and the size and how it's got smaller over time. You think about the size of the first mobile phone, but also think how often you're having to charge things and they're getting longer duration out of devices. They are indeed a huge part of the transition to net zero, and the technology is rapidly evolving as science looks towards creating the next phase of the mass-produced battery technology, such as solid-state and other lithium variants. But for the here and now, lithium-ion is the predominant battery that we'll see. Often they're manufactured as coins, cylinders, prisms, or pouches, and these cells are grouped together in a module and often in the thousands in the larger batteries. So I often get asked, are they dangerous? So it is a relatively new technology, so there's still a lot to learn from the aging process of batteries and what does that mean to their performance, their stability and safety, and only time will tell. But where the batteries are manufactured correctly, they're connected with a good quality battery management system, they're used correctly, charged correctly in line with the manufacturer's instructions, and used more importantly with the correct charger, they can be safe and stable. However, where we don't do this, or we allow them to be overheated, such as charging a laptop or a phone on a bed or under a pillow, or maybe allowing water to enter the battery casing, or we continue to use them when the battery becomes swollen, damaged or deformed, they can become a huge fire risk with devastating consequences. And sadly, I think we've had around about 7 people die in fires involving lithium-ion batteries in the last 12 months. So if you look around you now in the room that you're in, I'm sure you'll see them there. They'll be functioning as they should be, operating normally. And with some items, such as power tools, the battery can be detached and it's obvious that there's a battery involved. Whereas other items such as disposable vapes, electric toothbrushes or headphones, the battery is encased within the device. And often members of the public don't realise there's actually a battery in there. The reason I mention this is it causes a problem when a device comes to the end of its working life and we try to dispose of it. Recycle Your Electricals research state that last year we disposed of around 1.6 billion batteries in the UK, with the majority where the batteries are hidden within the device. If these items are not disposed of correctly, then we will continue to see significant fires and disruption in the waste industry. So the beauty of having a higher energy density in a battery means you can start to power things like transportation. And you look at all the different shapes and sizes which you can get from that. And with the larger batteries, we are now starting to see them in the larger vehicles as well. And we, as emergency services, are also embracing both the benefits and the challenges of working towards net zero. And you will start seeing, if you haven't already, electric battery-powered fire engines, battery-powered ambulances in use across the UK. Now, as well as transportation, we use batteries in our day-to-day lives and power banks of various sizes to support us all in our daily lives. So from boosting our mobile phone battery when away from the home, or installing uninterruptible power supplies to ensure business continuity in our buildings. And then as we move to using photovoltaic panels in our homes, we also seek to store the energy, maybe in batteries in our garage. And at the larger scale, to support the peaks and troughs of the national grid, we'll have grid-scale battery energy storage systems. So what happens when it goes wrong? So regardless, and this is a key thing about the technology, you've got to forget about the size of the battery. So regardless of whether it's a vape, an e-scooter, a car, a grid-scale battery energy storage system, the process and initiation courses are the same. The only difference is the amount of energy involved. And we talk about this phenomenon of thermal runaway. Now, I'm not a professor or a scientist, but my understanding of thermal runaway is where a cell within a battery breaks down and allows for the uncontrolled free of that high amount of energy within it. It leads to a chain reaction and that will heat up other cells around it, of which there could be thousands. That in turn can lead to the development of explosive vapor clouds, projectiles, and high-intensity jet-like flaming, which you may have seen in videos. And the causes could be simply something as, a hard piece of debris on the road striking a battery underneath a vehicle. It could be electrical abuse. It could be through poor DIY and people trying to manufacture their own batteries. Or it could be a lack or a defective battery management system, or simply using the wrong charger to overcharge the battery. And what we see is that where products have been designed and manufactured at a good standard, there will be a good quality battery management system as part of the charging system to protect the device. But often this isn't the case with the cheaper batteries, scooters and bicycle conversions which we see in the global marketplace. Excuse me. So what does it look like? So hopefully this video will play. Yep, it's playing, champion. So you'll see that this is a scooter in a flat. The dog's alerted to a sound. This person in the room goes across, alerted to the sound, isolates the scooter, but the thermal runaway has commenced. And the key thing which I need to get across to you in this video is that how rapid that fire or how that gas cloud develops, and how quickly that room filled full of smoke. So I wanted to show you this, I'm just waiting for it to load. I wanted to show you this video. Forget it's a car and look at the smoke. The firefighters think it's a carbonaceous smoke. And as the battery technology changes, we're more likely to see the explosive gas cloud that comes with that. So as battery technology moves between lithium-ion to lithium ferrous phosphate, you're less likely to see flaming and you're more likely to see explosions. And the parallels I draw is, so this is a car outside a building. How would this react if it was inside a building? But the key point for the firefighters, they think it's carbonaceous smoke which is given off by, well, if there is such a thing as an ordinary fire, whereas actually it's a flammable and toxic gas cloud. So as you can see from previous clips, when thermal runaway does occur, it does occur rapidly. And where items are charged and stored in the home, it can affect people's ability to escape in the event of a fire. So from a firefighter's point of view, fires involving lithium batteries are extremely difficult to deal with. Since we lived in caves, the main method of dealing with fires is generally by the application of water in most cases. Thermal runaway, however, is a reaction that will continue in the absence of oxygen, so even if we immerse the batteries in water like they have done here, the reaction will continue and the production of the flammable gas will continue to be produced. As such, depending on the size of the battery, they can become protracted incidents for firefighters to deal with. So after that, so what can firefighters do? So there is no one single solution anywhere in the world that will deal with the extinguishment of lithium-ion batteries. Our objective as firefighters is to try and prevent further propagation of the cells around the one that's affected and prevent further thermal runaway. We may struggle to put the fire out, but we may prevent further thermal runaway through cooling. But this takes time, and these are protracted incidents, and they can last from hours to days depending on the battery size. The difficulty we have is getting water into the cell. The cells are designed in a way to be weatherproof and protected to stop water getting in there. Hence, often the best method to deal with this is through a controlled burn. However, we recognise adopting a tactic to allow a battery to burn out is easier to achieve in maybe the rural areas as opposed to busy city centres. In my role with NFCC, I've been in contact with fire and rescue services and governments across the world, and there's broad agreement that there is no one single solution or silver bullet, as it were, to deal with the incidents. I think what we'll end up with is a range of products and markets, but often that safe tactic is to allow for controlled burn and protect the area. I think what we'll end up with is a toolbox full of solutions, but there is no one size fits all. But the science is still continuing to research how we can actually do this. But it's not uncommon if we have an electric vehicle fire to hear of 10,000 litres of water being used in a battery fire involving that car. And the question I'd pose is, did it actually extinguish the fire? Or did the battery consume itself? And what we've done is we've just washed lots of heavily contaminated water into the drainage system and caused greater pollution. With the smaller devices like scooters and bikes, often the device itself, by the time the fire and rescue service arrive, will have extinguished itself and consumed itself. But with the larger devices such as vehicles and battery, it's likely that the incident will still be developing when the fire and rescue services arrive. What I should have said about smaller devices as well is generally they will become almost a piloted ignition to something else within the room. The firefighters are met with a fully developed fire which has been triggered. So it's a bit like having a firework go off in a room, as it were. So looking at vehicles, and you ask, are cars the problem that we perceive? So I work very closely with colleagues in Australia, and there's a really good website there, evfiresafe.com. And evfiresafe would suggest, based on the current knowledge, they collect a lot of stats from across the world, but what we're seeing is electric vehicle fires are not the issue they think they are. Yes, you're more likely to get thermal runaway when it's on charge or after charge, but it's not an everyday occurrence. And I do think we need to try and dispel the myths. Not every electric vehicle will burst into flames, and not every collision will end in thermal runaway. If you think of some of the manufacturers, we believe there's around 600,000 Nissan Leaf in use across the world, but we've only been able to manage to find about 20 fires that have occurred within the Leaf. Tesla have produced around 3.6 million vehicles globally since 2008, and they've been using lithium-ion batteries since 2021, and yet we only believe there's been around 200 or so fires. We are always going to have fires in vehicles. At the moment, though, electric vehicle fires are rare. Electric vehicle fires involving the battery pack are rarer again. I think it's really important to separate the two out. The caveat I would add, though, is this is all about new data on new vehicles, many under warranty, so you think about what will it look like in 10 years' time. If you think about charging cables that connect these vehicles to the infrastructure, how often are people likely to replace these when they begin to fail? They're expensive. And if I ask you to maybe reflect on the state of some of your charging cables that you've got around you now, at your home or in the office, and how you're charging your mobile phones or laptops. Once those chargers become old, will you replace them with another manufacturer-approved charger from the manufacturer's shop, or will you use a cheap replacement from the global marketplace? So then if you draw parallels to the electric vehicle market, so what's the likelihood of the public replacing a car charger from the manufacturer with another expensive one, as it were? So whilst I don't have a definitive data picture, what we are seeing is more injuries from fire involving bikes and scooters than that in vehicles. The main difference being that these are charged inside the home rather than outside. Many are purchased via the global marketplace. You think, do they meet UK standards, or indeed is there a standard in place? Many of the fires sadly involve those people who have engaged in the gig economy, and where the bike has had a poor quality e-bike conversion. And what we find is where people are living hand to mouth in the gig economy, they want the bikes to charge quicker, ride faster, and the battery to last longer. And they're converting any bicycle and adding an electric battery and motor through conversion kits, again sourced from the global marketplace. The fire safety problem is often exacerbated by those involved in this are living in high density housing, such as houses in multiple occupation, charging their bikes together, often in the escape route. But I do think it is important that we separate out what I call the good, the bad, and the unsafe. If we make wise shopping choices from reputable shops with recognised brands and look after our equipment, lithium-ion batteries will help us in our day-to-day lives. If we constantly look for the cheapest item from the global marketplace, look to buy what I call fast technology, and don't follow the manufacturer's instructions, then we're likely to see more fires, deaths, and injuries. And then, in terms of the bad and safe, it is around those poorly installed conversion kits. It is possible to convert a bike to an e-bike, but it has to be done in a safe manner by a competent person. Universal charger is another area of concern whereby you can't connect a charger to a device, and you might think that because the plug fits the device, it'll be fine. But all devices take different charges, and overcharging a device is a huge source of fire. So there are simple things you can do to keep yourself safe, and there's a QR code there if you want to scan it. And I've used London Fire Brigade's website because it's a really good source of information on how you can keep yourself safe. We always say, buy from a reputable dealer, use a charger that's provided with the device. You should always have a working smoke alarm on your battery. Unplug your charger once the battery's charged and let your battery cool down before charging. And charge your battery on a hard surface. And what we say you should never do is never charge your battery when you're sleeping or away from the home, or charge your battery in an escape route or in front of an exit door. So, taking the subject towards car park fires, we've seen some significant fires globally in enclosed car parks, and whilst the number of injuries and deaths is low, the economic cost is significant in addition to the challenges of firefighters. Cars are becoming larger, and as such, the distances between them in car parks is smaller. This allows for rapid fire development once a fire occurs. It's now suggested from the Research Institute in Sweden that the rate at which a fire will spread car to car will occur every 30 seconds once the first one is alight. When I first started looking into this, I thought electric vehicles perform differently when they're involved in fire. The reality is, from the fire tests that have been done, the heat release rate is the same or the equivalent to an internal combustion engine vehicle. The only difference being that the electric vehicle will sustain the burn for longer. Therefore, the issue we have with car parks is not just about electric vehicles, it's all vehicles in car parks. And we've got to remember, at the moment, there's still more likelihood of a fire in a combustion engine rather than the battery pack of an electric vehicle. So looking at the largest types of batteries that we're probably going to come across is around grid-scale battery energy storage. And we need these to capture and store our energy and deal with the peaks and troughs of demand in the national grid. Battery energy storage arrays are being deployed across the UK. They'll generally resemble designs like this, or there'll be variations in terms of the number of cabinets that you'll see on a site. I often think of battery energy storage as the nation's power banks, and they range from the huge ones linked to solar farms through to smaller domestic ones for housing, which are becoming more popular, and the UK needs them. When I grew up around cities, you had gas holders, which stored my gas and energy that were needed then, and I often think about these as a modern equivalent of gas storage. We're going to see exponential growth in this area, and it's an area with limited guidance. There are various documents that exist, but are geared more towards the United States and their markets. National Fire Chiefs Council have produced, and I'm busy revising guidance in this area, but it's aimed at the fire and rescue services rather than the public. They are infrastructure projects progressing via a planning route, and they're not subject to building regulations. As such, fire and rescue services, until recently, may not have been aware of their presence, and this has been resolved through working with government to issue revised planning practice guidance. The main hazard for firefighters is not knowing what they are faced with when an incident does occur, and the planning practice guidance helps with this to make sure we're notified of the locations. Whilst they are required to support our energy infrastructure, there has been some opposition locally to their deployment. At the domestic end of the range, battery energy storage systems are used to capture the energy which you'll gather from photovoltaic panels on houses. And there's been recently some guidance released on this, and installers should be using this now. One of the important issues for fire safety is around the siting of where you put a battery in a house. And one of the significant changes, or the key things in there, is, it shouldn't be put in a habitable room. Preferably it should be outside the dwelling. It shouldn't be in a loft space. The reason being that it could well be that there's a fire in the bedroom beneath and the roof comes down on the firefighters when they're dealing with a fire in the bedroom, and not in the basement, again, for difficulty in getting in there should it be involved in fire. We still have concerns again over do-it-yourself projects and the repurposing of batteries, and we have seen fires in homemade battery energy storage systems, and you can still presently buy second-hand electric vehicle batteries in the global marketplace. But I really would strongly advise against this and only use a competent and experienced installer in this area. So thinking about the life cycle of a battery and a product, when it comes to the end of its life, we need to make sure we avoid scenes such as this, with the incorrect disposal of lithium-ion batteries. Last year, we had over 1,200 fires involving the waste industry as a result of lithium-ion batteries being put in the household waste and incorrectly disposed of, often occurring when a battery is crushed whilst hidden in a device or a pile of refuse. This results in the rapid uncontrolled release of energy and the development of a fire within a waste transfer station or a refuse van. Not only are these challenging incidents for firefighters to deal with over days, but they have a huge impact on the environment and the community. The loss of a waste transfer station can have a significant impact on the local authority if they are unable to process the rubbish for an area, and you're going to start to see the bins backing up very, very quickly. So rather than dispose of your electrical items in the household waste, we're advising people to use the Recycle Your Electricals website and the postcode finder on there to find out where you can recycle or dispose of your electrical equipment. This will help the environment and also help reduce the number of fires that we're seeing within the waste industry. And the QR code's there if you need to scan that to take you to the website. So really, in closing, I'll leave that slide hanging. If we make wise purchasing decisions and we look after our batteries, we follow these instructions, these batteries can really help us in our day-to-day lives. But fail to follow these simple steps, and I suggest we are putting ourselves and others in the community at significant risks. And I'm happy to take any questions.
I don't know how we do virtual applause, Phil, but we should be doing that now because I really enjoyed that, and I'm sure everyone on the call has learnt something. I mean, the clue is in the title, Knowledge Miles. There we go. You're getting lots of applause, look, in the on the screen there. That's fantastic. Thank you, everyone, for doing that. I'm sure Phil really appreciates it. You have stimulated plenty of questions, which is no great surprise given the topical nature of the subject. So I'm going to rush into those because we've only got 20 minutes to deal with them. But as I said right at the beginning, Phil has very kindly agreed to take those questions and handle them as best he can. There is one question about insurance risk. I'm not sure Phil is able to answer that, so I won't put that one to you. But I'd suggest that one's better targeted at the insurance industry. But Phil, do you want to make a comment on that from an insurance point of view? Is that something? The question is, how has the insurance industry responded to the risk? Is that something you're aware of or not?
I mean, I have had discussions with insurance, and I've shared, a similar presentation with insurers around this, and really it's for them to then make decisions around how these should be addressed. But what I would say is the whole world is evolving. This technology isn't going to go away, and it's part of our day-to-day lives now. And as an insurable loss, insurance companies will have to make decisions and maybe provide advice certainly to business, and may make stipulations, but it really does go back to whether you're buying a small battery or a big battery. If you follow those things about making sure it's all about the quality, the standard of the equipment that you're buying, and it's a maintenance and the preventative maintenance that goes with it, that will help you and prevent you having a fire with it.
Sure. Yeah. No. Thanks, Phil. Thanks for handling that one. I didn't expect you to handle that so well. So brilliant. Thank you. So Colin Wells has asked, there are a few extinguishers currently being marketed as lithium-ion extinguishers. Are you aware of any that actually work effectively without giving the names of companies that are actually doing that, please?
It's a really challenging thing to get. It's a really challenging tactic to use because, as I say, if you can imagine a battery, and the battery will fail, and what you've got out of there is gases and flames coming out at high pressure. And I still haven't seen anything which will really overcome that pressure. Because imagine water coming out of a hose, and what you're trying to do is go against the flow of that and introduce an extinguishing medium. So it may well be that the extinguishing medium is capable of dealing with the battery. It's the application and getting that application into the battery cell. And often what I see is these batteries are hidden away in vehicles. So it could be right in the bottom of a vehicle. It could be within a device. So another problem with the application is trying to find the cells which are actually involved, because you could have thousands of cells within the battery. But what you don't want to do is start another reaction somewhere else and make things worse, as it were. It's almost like you need a laser guided device which will pinpoint the particular cell of origin and deal with it. And I haven't seen that technology, and nor have colleagues across the world.
Yeah. So the advice to people would be to contact the local fire and rescue service if they've got a risk that they want covering, if the fire risk assessor's been unable to provide them with that information. Is that fair?
Yeah. It's more, I think people in a commercial world need to accept that these devices are coming into the property. So they're coming into the buildings. And what I'd advise people, if you think about smoking in the workplace, if I draw parallels with that, where you provide people with a place to go and smoke, they'll go to that. If you don't provide the facilities, it can happen anywhere in the workplace. And it goes back to, people before the smoking ban came in. But I do see similar things here where if we accept people are going to bring batteries into the workplace, whether it's through a tablet PC or a laptop, or whether it's an e-bike or e-scooter, are people going to be able to charge that? Where can they charge it? And if commercial organisations don't provide that for their staff, if you think about cycle to work schemes, we need to have facilities within our places of work where people can charge them safely. And if I think back to when I worked in fire safety previously, you may have turned a blind eye to a bicycle being chained to a radiator within a staircase, providing it wasn't an obstruction. But with an electric bike now, that's not an option. It's ignition hazard that's happening in the staircase, and we need to start designing our buildings to accept that we need to accommodate new technology, new ignition sources within the built environment.
Okay. Thanks, Phil. We've got another question here from Paul Sheedy, who's asking that he's based on the 39th floor of a skyscraper. There's a vast 3-story car park under the building. Why would these risk to high-rise buildings never do full evacuations? I'm not sure never's correct, but over to you.
So, I mean, it's more, I guess it's more a question around building design than the batteries. And we've got to remember the lithium-ion battery is an ignition source, of which there are many more within buildings. And I think really it comes down to the fire strategy of the building, how it was designed. And like any other additional fire loading that goes in there, a fire risk assessment should take place. And what we need to understand is how the additional risk which has been put into place impacts on the existing fire strategy, the evacuation strategies, and how is that building going to perform in the event of a fire. So maybe not just looking in isolation at lithium-ion batteries, it's thinking about the whole entity and taking a holistic approach.
Okay, thanks very much. Right, so Alistair Milner's asked, what type of fire suppression system would you suggest in a UPS IT comms room containing large-sized lithium-ion batteries?
So again, it's as battery technologies change, and it depends on the type of battery technology that's being used. With lithium-ion, you're more likely to get flaming combustion. As we move towards lithium ferrous phosphate as a battery technology, which is happening, we're starting to see less flaming and more of an explosive gas cloud. So what we need to start catering for, I think, in all our fire safety design documents and approaches, the thought of deflagration and how do you actually deal with an overpressurization of a compartment. And certainly within the battery energy storage industry, and I talk to colleagues from NFPA or Pacific Northwest Laboratories, part of the things they're advocating is almost a proactive approach to explosion management rather than a reactive. So rather than wait for a container or a room to be overpressurized, accepting that it maybe will, and actually venting that through maybe an automatically openable vent, like we've seen in staircases elsewhere, rather than waiting for it to overpressurize. But in terms of, it is a reaction which will occur in the absence of oxygen. So I'm not aware of the effectiveness of the likes of, gaseous suppression systems in terms of dealing with that, if that makes sense.
Yeah.
I think it's recognizing that the batteries are different, and if you are changing from the likes of your lead acid batteries, which did have a fire risk and a gas risk of their own, there's just a new challenge with that, and it just needs to be thought through where you put that battery room in the building.
Thanks, Phil. Nice segue, actually, from what you've just said from Catherine Allen. She's asking, can you tell us more about your work with the Australian Fire Service? I didn't know you'd done any work with the Australian Fire Service. That's very interesting. And has there been work with the USA Fire Service, which you did just mention? So, so the international connections, because it is a global challenge, as we know.
And just for the record, it sounds glamorous, but I've had no international travel to Australia or America out of this work so far. What the American one, UK Home Office signed a memorandum of understanding with the US Fire Administration, which is all about sharing information, sharing problem solving around different areas. And one of the areas is around energy technology. So with that, we're connected to FEMA in America, the US Fire Administration, and on that is the likes of people involved with research, people who would be writing standards and things like that, but also the likes of firefighters from San Diego, from New York, and we're just sharing knowledge, and that's that work basically. What's interesting is when I first started this work, I thought this was a UK problem, and when I start to talk to colleagues across the world, we're all in a similar position. New York have introduced legislation around the use of e-scooters, the maintenance of e-scooters, and the sale of e-scooters, about where they can be sold and who can repair them. But the UK hasn't gone down that approach. Bear in mind, a lot of the e-scooters that we have are illegal, and the only e-scooters which can be driven on public roads are the ones on the local authority schemes. But if we look around us, they're everywhere. So you've got to think, will regulation work? The Australian work is more through connections with the likes of EV Fire Safe, who are work towards the Australian Department of Defence. I do have connections to country fire authority and things like that, but there's no direct work, as it were. There's no products being designed or anything like that.
As a form of reassurance for everyone, actually, as late as last week, there was a World Fire Congress in Washington where the Home Office and National Fire Chiefs Council were represented. There were 50-something countries apparently at the event, and I've absolutely no doubt that lithium-ion batteries were part of that. And I think this is in the post-Grenfell era that people have recognised that, the international connections are not just about jollies. They are actually really about learning and sharing and preventing tragedies. So it really is important work. So a great question. Thanks very much, Catherine. Right. So Stephen Palmer, does the data comparing the likelihood of fires between EVs and IC internal combustion engine vehicles only consider fires started by a fault with the vehicle, or does it include external factors such as arson or cigarettes?
And this is why we need this is a really good question. And a lot of the things that we'll see an electric vehicle on fire. So people automatically think it's a fault with the battery. And that's just trying to explain in my presentation that we are always going to have car fires. We are always going to have arson. We are also always going to have maybe a fire within the dashboard area, or another type of electric fault within the vehicle. And we need to separate out these different types of fires. And this is why I'm saying, in terms of, I think with electric vehicles, because of all the safety systems and computers that we're seeing on there, we're seeing less collisions, but also less fires. But then actually less again in terms of the fires within the battery. And I think that's due in part down to the complexity of the battery management system, which is monitoring the state of health and the charge of the battery. And that doesn't exist within the scooters and the bikes, e-bike conversions. So generally, and I have started to hear about cars which now give a proactive alert to say that the battery is becoming stable and not to use the vehicle. So that appears on the dashboard.
Okay, no, thanks very much. So really interesting one, and you've not linked in. And I know we did discuss this beforehand, but this is a question from the UK Chamber of Shipping, Ellie Norris. Additionally, what training and guidance can be provided to shipboard crew who are the only firefighters available for these incidents?
And this has proven to be a really difficult challenge across the world. And I know of colleagues who are working with the shipping industry in this area. There has been tests being done as the best way of dealing with it. But if you imagine the analogy of the car park, where the cars are parked close together, if you're doing the mass transportation of electric vehicles, and we have seen some significant fires and significant insurance losses, let alone the loss of life across the world in this area. But what you have is a rapidly developing fire, but your car park's floating at sea, and there's limited means of escape from that. It's a really challenging area, and I don't think we've got the answers to it at the moment. Ships are equipped with suppression and things like that, but I would suggest it's a limited capability in terms of the access that's required to deal with the car that's involved, and also in terms of how rapid the fire will develop. So I can't really give specific advice, but what I would say, it's a really challenging area, and I know that there's a lot of interest in this across the world.
Yeah, can I suggest that Ellie contacts you? Your email address is down there, because I think that's certainly one that we're interested to follow up, because it's not only when they're at sea, of course, it's when they're in harbour, when they're in port, becomes a very different problem altogether. Yeah, okay. So there's another one there on port locations, which we've just covered. Sorry, I'm just trying to concentrate on your questions and see if we've got some good questions here. Right, okay, Steve Burwell from Kent. Are there any certifications being developed around battery storage within premises covered by the fire safety order? To be an interesting one for both fire risk assessors and regulators, of course.
Not that I'm aware of. At the grid scale, there are maybe ways to demonstrate that you have bought what I would say is good quality systems and equipment. And there's a organization in America called Underwriters Laboratory, who provide a list of equipment that has maybe gone through a full-scale fire test, and you understand how that can be developed. In the UK, we haven't got anything like that at the moment. The closest we have at the moment is the publicly accessible standard 63100, which is around domestic battery energy storage. But there is an absence of that guidance at the mid-scale and the grid scale for UK-specific technologies.
Okay, thank you. And one that should be of interest to everybody, because we've all got them at home, from Tessa Kershaw. what can householders do to try to prevent lithium battery fires in their homes? I know you've covered some of this, but perhaps you want to elaborate a little bit on that.
Yeah, I think it comes back to making those wise shopping choices. If you're seeing something that's really, really cheap and it looks really good, you've got to question how it's been built, how it's been put together, what's the controls in place. Really, for people to keep safe, it comes back to not buying, always buying from reputable locations. E-bikes are good. Get one with a decent motor. Don't get an e-bike conversion, or at least get that done by a competent person. So it's all about making the wise shopping choices and procurement choices, as it were, before things go into the home. And then in the home, it's following that advice. So think about where you're going to charge the device. If it's a smaller device such as a vape, maybe a kitchen bench or a hard surface, which isn't going to readily ignite if if it did catch fire. So not leaving your vape on the side of the sofa, for instance, while it's on charge, and being something which can ignite, leaving on a hard device. For the larger things like bikes and scooters, it's making sure that you're not charging that when you're asleep, and make the distinction of not charging at night from not charging asleep, because obviously people work different shifts, but not charging when basically you're not alert to what's going on around you and when you're away from the property, because it comes down to that first video I showed. The person in question, even though they disconnected the scooter from the supply, it still developed into the fire and it started the thermal runaway. And then just keeping an eye on the products that you've got, looking out for if the battery's becoming hot, if it's swollen or deformed, and then, not using it beyond that point. And the key thing is then just don't put it in the household waste. Take it down to your local authority recycling centre or use that website, and it'll tell you where batteries can be recycled or disposed of. Because the reason that you might be disposing of that is because it's a problem for you. So now you've just put an unstable battery in the household waste, and suddenly it's a problem for the whole community, because suddenly they've lost it could be their bin wagon, or it could be the waste transfer station that's gone. And the other key thing is to have a working smoke alarm and making sure that you don't charge your devices within the escape routes of a property.
Okay, and a home one for you. Not Tyne and Wear, but Royal Berkshire Fire and Rescue. Is there going to be any national operational guidance provided by the NFCC to support services in creating a policy position for dealing with these fires and the disposal of waste?
So yeah, I'll take that one offline, because yes, there will be.
Yeah, absolutely. Okay. So we've got, I think we've certainly got time for at least one more question. Will the guidance for grid scale energy storage systems review to align with other international codes and industry best practice, particularly with regard to container separation?
Yeah, and this is a really topical area. So what we need to focus on basically is how will an incident in a battery energy storage container be confined to the container of origin? And in the past, what was said to people is you've got to have mandatory distances between them. But as risk assessment has changed and shown, there's a number of different solutions that could be applied to actually dictate that distance. And it could well be that it could come down to using fire-resistant construction, for instance, or it could be separation. But there's a range of different things which could be used. But yes, the revised guidance does look at events which have happened around the world. It's around what other standards around the world have actually included. So we're trying to have more of a, rather than be so prescriptive, be more risk-based.
Yeah. I mean, it goes back to that comment I made about that World Fire Congress. I mean, clearly, you don't need to pull everybody into a country to do that, but it's a good kickstart for the connections and networks that people need to build up, because obviously you don't know what you don't know until somebody shares the learning from incidents and around the world. People aren't going to be able to pick it up and use it and keep people safer. So there's a really good one here. And thanks from Hugh Taylor, who's talking about, he's saying he's sure you're aware of them, but the Health and Safety Executive Science Division in Buxton does a lot of work in this area, and he's got connections. So I'm sure, Hugh, you can contact Phil directly on that one. But do you want to make a comment about the links with
Yeah,
HSE?
and we all, so Department for Energy Security and Net Zero orchestrated a health and safety governance group for grid scale battery energy storage, and health and safety executive, or I believe, I'm not sure if they still are, but we're the vice chair of that group. And National Fire Chiefs Council and others attend that meeting too, and that's where we talk about such issues. So I guess what I'm saying is we do have all those connections, but I'm happy to be connected to others as well.
Okay, well, I'm very conscious that there's a lot of people on this call who are very busy people, like I know you are, Phil, who want to get on to doing other things, but hopefully everybody will be able to take something away from today's discussion. I've been, I've learned things. There's absolutely no doubt about that, and I'm sure everybody on the call has. And you're getting more applause here, Phil. So you've obviously done a great job. So well done, and thank you for showing your appreciation. Those people who are clever enough with the technology to show they can put a clap on there. It took me about 8 months to learn how to do that. But here's on the screen. Here's some forthcoming lectures as well. As you can see. I'm not sure Sir Isaac Newton himself is going to be talking, but somebody's going to be talking about a genius and/or a flawed character in a couple of days, actually. And then on the 22nd, the Achilles heel of AI. Everybody's talking about AI, so I'm sure that's going to be a fascinating session as well. And then on 23rd of May, are we asking the right questions about profit? Gosh, that's going to be an interesting one. Phil, I've no idea how you managed to get so much into such a short space of time, and I know you burnt the midnight oil literally to put that presentation together and get it into a condensed version and a really easy to understand version, which is really difficult to do on such a complex subject. So thanks very much indeed, and I would encourage people on the call to contact you directly, although I'm sure that everybody is going to be provided with the presentation. It's accessible through YouTube. And thank you to the audience for your participation. I'm overwhelmed by the number of questions. It's actually quite difficult chairing a session where you've got so many questions being thrown at you. So I apologise to those people who have not aired their questions, but all those questions are going to be passed through to Phil, and Phil will ensure that either they're answered by somebody in FCC or he does it personally. So thank you very much indeed for listening, and one final round of applause for Phil. Well done, Phil. Great stuff. Thank you. Goodbye.
Yeah, bye-bye.